Yes, I'm audible to everyone. Okay. मेरी स्क्रीन दिख रही है सबको? Okay. So we will continue the remaining part. Okay. So yesterday we have talked about the concept of the important register, that is SCON. Okay, serial communication register, and we have seen each and every bit in detail. Okay. Even I have told you there are four modes: mode 0, mode 1, mode 2, and mode 3, and we are selecting those mod with the help of SM1 and SM0. These are the 6th and 7 bits. I have explained you the first mod is synchronous communication and the remaining three are asynchronous. We have also seen what is a baud rate and what are the fixed baud rates. And for mod 1 and mod 3, the baud rates are determined by a timer 1. So everything will be explained in a proper sequence. Just try to understand in for time being that these two we have a fixed baud rate that depends upon the crystal. This is 1 by 12th the crystal frequency. Mod 2 will work under 1 by 32 the crystal frequency or 1 by 64th the crystal frequency. Okay, so they are fixed. Now we have to understand each and every mode of operation. Okay, so you can just write down the heading as modes of operation. We are going to see each mod in detail. Okay, so just write down modes of operation. Do not write anything, do not draw the figure, because the explanation of this is more important. So we will see the explanation of this. Okay, and we will see how these mods are the operations are operated and what are the different baud rates. Okay, what are the different baud rates? So when you talk about the first mod 0, if you see on the screen. Okay, if you see on the screen, now under this mod 0, we have already talked about that in this mod data is transmitted and received by RxD pin and TXD pin. Now when you talk about this mod 0, this is a 8-bit shift register mode. Try to understand what do you mean by 8-bit shift register mode. Now in this mod 0, data are transmitted and received through RxD pin, and the TXD pin output the shift clock, and this is used to synchronize data transmission and reception. Already I have told you in mod 0 we go with the synchronous. We go with the synchronous. So what is the scenario? That your 8051, please try to understand the concept, this is important. You have two pins, one is called as TXD and other one is called as RxD. Under the synchronization, you know that both the transmitter and receiver section should be the clock should be same, or else there should be a synchronization. So how the synchronization is achieved? The synchronization is achieved in such a way that this TXD will be used for clock generation. TXD में हम बोल रहे थे कि हम डेटा ट्रांसमिट कर रहे थे, लेकिन यहाँ पे ऐसा नहीं है. यहाँ पे TXD is used as a clock that will generate the clock. और सपोज दूसरा दूसरा सपोज 8051 है और ये दोनों के बीच में डेटा ट्रांसमिट करना है, सो यहाँ का भी जो TXD है वो भी क्लॉक जनरेट करेगा, एंड दिस क्लॉक शुड बी द सेम to achieve the synchronization, to achieve the synchronous communication. Then where the data will be transmitted? The data will be transmitted or received through RxD. Now this is the twist. हम RxD में बोल रहे थे कि डेटा सिर्फ रिसीव होगा, लेकिन अंडर द मॉड 0 RxD पिन विल बी यूज्ड फॉर ट्रांसमिशन एज वेल एज रिसेप्शन. अगर ये 8051 ट्रांसमिट कर रहा है, सो दिस विल वर्क, RxD विल वर्क एज अ ट्रांसमिशन. और 8051 ये अगर रिसीव कर रहा है, देन दिस विल रिसीव थ्रू द RxD पिन. सो दिस विल बी कनेक्टेड विद दिस. तो 8051 ट्रांसमिट कर रहा है, RxD पिन रिसीव कर रहा है. जब RxD पिन ट्रांसमिट करेगा तो दिस RxD पिन विल रिसीव. So what I meant to say that the data will be transmitted from RxD and the synchronization or the clock frequency will be achieved through the TXD. So this is RxD, where you will be able to transmit the data, you will be able to receive the data, and TXD is used for the generation of the clock. That is the meaning of this. Okay, so clock. So TXD pin outputs the clock, TXD pin outputs the shift clock, and this is used to synchronize the data transmission and reception. On transmit, the least significant bit LSB is sent or received first. ओके, आपका LSB क्या है? आपका LSB है D0. तो आप जब भी ट्रांसमिट कर रहे हो तो D0 will be sent first, then D1, then D2. Similarly, when you are receiving the data, D0 will be received first, then D1, D2, and so on and so forth. So that is a function in mod 0. यहाँ पे क्या दिखा है? See here, your TXD, आपके mod 0 में आपने क्या लिखा था? In your mod 0, if you see here, your mod 0, in your mod 0, you have the baud rate as 1 by 12 the crystal frequency. वो दिखाने के लिए this is the diagram. अब ये डायग्राम क्या कर रहा है? सी दिस डायग्राम. आपके TXD में क्लॉक जनरेट हो रहा है, आपके RxD में आप ट्रांसमिट कर सकते हो, रिसीव कर सकते हो. इसलिए एरो देखो क्या है, ट्रांसमीटर और रिसीवर का एरो है. You know that before you transmit, the transmit buffer should have the data. After you receive the data, your receive buffer should have the data. What about the TXD? The clock is 1 by 12th crystal frequency. Your crystal frequency is here, and 1 by 12 is divided by 12. So you have these two blocks. Crystal frequency will be generated, that will be given to the divide by 12 block, where it will be divided, and the clock which will be generated, ये जो clock दिख रहा है, that will be 1 by 12th of crystal frequency. 1 by 12th of the frequency. Okay, so this is the frequency which will be generated, and 1 by, so you know T is equals to 1 by F. Whatever the reciprocal you take, you will get the time period, and that time period is the clock. Okay, so here, as I have told you, that your baud rate is fixed. So your baud rate is 1 by 12 the crystal frequency. तो ये ऐसा जनरेट होता है your clock frequency. I hope you have understood mod 0 operation. Any question, please ask. Mod 0. Any question? Am I audible? Any question you have? Louder. Any question? Louder. Okay. So please read about the transmission, read about the reception. Already we have done this, so no explanation is required from my side. Okay. Then also one important thing, that transmission begins by an instruction that uses the SBUF as a destination register regardless of the state of TI. When the transmission is complete, all 8 bits have been sent. The TI bit of the SCON bit is set automatically. Yeah, yesterday's lecture I have explained you about the TI. Okay, similarly for RI also the same explanation is available. Okay, so I request everyone to go through this explanation properly. Then comes to the next one, that is mod 1. Then comes to the next one, that is mod 1. प्लीज रीड दिस ऑल्सो, baud rate for mod 0 जो मैंने अभी आपको बताया. Okay, everything I have explained you, please go through this. Now comes mod 1, that is a standard 8-bit UART mode. So I have told you mod 0 in synchronous communication, mod 1, 2 and 3 is asynchronous communication. So mod 1 में क्या हो रहा है? Okay, so to understand this mod 1, try to understand the concept that here here you are transmitting 8 bit UART, mod 2 में 9 bit, mod 3 में 9 bit. अब 8 bit UART में क्या हो रहा है, see here all of you, this mode transmit 10 bits, this mode transmits 10 bits through TXD pin and receives through RXD pin. ओके, तो यहाँ पे क्लॉक जनरेट नहीं हो रहा है क्योंकि आपको पता है in your mod 1, in your mod 1 your baud rate is variable, it is not fixed, and it is set by timer 1. Okay, and it is set by timer 1. तो यहाँ पे as it is a UART, you are transmitting 10 bits. अब 10 bits कौन कौन से, because it is UART, so 10 bit means 8 your data bit, one start bit, and one stop bit. So 1 plus 8 plus 1 gives you 10. So 10 bits are there. A start bit always 0. 8 bit data LSB first. This is also important. पहले D0 जाएगा, and then stop bit it is always 1. So remember start bit is always 0. वाइवा में पूछ सकते हैं, your start bit is always 0, your stop bit is always 1. Start bit is always 0 मतलब वो ऊपर से नीचे जाता है और उसके बाद एक्चुअली डेटा जाता है, और बाद में स्टॉप बिट इज ऑलवेज 1 मीन्स डेटा पूरा खत्म होने के बाद ये आपका जो है ये आपका डेटा बिट है D0 से लेके D7, उसके बाद यू हैव स्टॉप बिट विच इज ऑलवेज 1. तो दिस इज द सिनारियो, दिस इज सॉरी दिस इज 0 start bit, this is 1 stop bit, or in between you have D0 first, then comes the last D7. Okay, so collectively it is 8 plus 1 plus 1 gives you 10. So 10 bits are transmitted through TXD pin and receives through RXD pin. The programmer can set its transmission reception rate using timer 1. Your transmission and reception का जो rate है, that is called as a baud rate, and your baud rate depends upon your timer 1. Okay, so timer 1 के related वो baud rate जो fix होता है, that thing we will see very soon. Okay, but just try to understand your baud rate is variable and it depends upon your timer 1. Okay, it depends upon your timer 1. Now to understand the transmission and reception in mod 1, you have a figure. So try to understand the figure. For transmission, this is the figure. For transmission, this is the figure. And for reception, this is the figure. I will show you both at a time. Yes, I will show both at a time. So when you are transmitting, so transmitter section is up 1, नीचे you have a receiver section. Transmitter में क्या हो रहा है, write to SBF 8 bit data, SBF में 8 bit data आ गया, it is given the 8 bit data is here. So D0 to D7, your start bit is 0, that is getting added with the data bit. Then you have a stop bit which is always 1, which is getting added, which is getting added. Now you are transmitting the data, so you have the frame. Now you have this frame, this is called as a frame. Can you see properly? The frame consists of start bit 0, the data is D0 to D7, and then your stop bit 1. So this becomes one frame, this becomes one frame. Okay, and then you are transmitting this data. So this is a 10 bit parallel to serial conversion. This is a 10 bit parallel to serial conversion. You have this data that is taken from the SBUF. From SBUF you will be having only the data D0 to D7. Then after that you are adding stop bit and start bit. Okay, whenever your SBUF is, when you are transmitting and when your SBUF is full, so transmit buffer empty, so your TI will be 1. TI के बारे में मैंने already explain किया है. So that it shows that your SBUF is empty, your SBUF is empty, and now the other data can be accommodated in your SBUF. तो TI का function मैंने already आपको बताया था. Okay, so that is the meaning. And you are transmitting this, so you require a clock. So clock will be taken from the timer. The clock will be taken from the timer. Okay, baud rate depends upon timer 1. मॉड 0 में था फिक्स्ड 1/12 ऑफ क्रिस्टल फ्रीक्वेंसी, यहाँ पे ऐसा नहीं है, इट डिपेंड्स अपॉन योर टाइमर 1. ओके, देन योर डेटा इज अवेलेबल, देन इट इज ट्रांसमिटेड सीरियली। तो पहले स्टार्ट बिट जाएगा, बाद में D0 जाएगा, बाद में D1 जाएगा, बाद में D2 जाएगा, डॉट डॉट डॉट, बाद में D7 जाएगा, लास्ट में स्टॉप बिट जाएगा। तो दिस इज अ 10 बिट पैरेलल। रिसीवर में क्या हो रहा है, आपका डेटा रिसीव हो रहा है, 10 बिट रिसीव, 10 बिट सीरियल टू पैरेलल कन्वर्जन। आप डेटा सीरियली रिसीव कर रहे हो, आप सीरियली रिसीव कर रहे हो। ओके, सो यू हैव रिसीव्ड द स्टार्ट बिट, then you have received D0, then you receive T1, then dot dot dot, then you receive stop bit. So this is a frame which is generated, which is received. Okay, obviously there will be a clock, then it is, you are extracting the data, you are extracting the data, and then this will be given to the S buff. So there is some connection between RI and the S buff. S buff khali hai, indication is given by RI. S buff full hai, the indication is given by RI. Receive interrupt, receive interrupt. So data received in the S buff. Okay, data received in the S buff. Now when you talk about this mod 1, the important thing is that your interrupt flag Ti is set once all the 10 bits have been sent. और receiver में क्या होता है, the stop bit goes into bit RB8 of the SCON register. This is important, this is important, this is important, I am writing down here. Now during the reception, for reception you have a down, you have this particular figure niche wala. Now whenever you are receiving the data, the stop bit goes into bit RB8. RB8 हमने देखा है इन योर एसकॉन रजिस्टर, एसकॉन रजिस्टर में हमने ये RB8 देखा है। तो वेन एवर यू आर रिसीविंग द स्टॉप बिट, आपका स्टॉप बिट कौन सा है, आपका स्टॉप बिट ये वाला है, ये। सो दिस स्टॉप बिट will be saved in RB8 bit of SCON register, RB8 bit of SCON register, and the baud rate is variable and it is determined by the timer 1. Okay, तो ये इतना याद रखना है कि it is determined by the timer 1. वो कैसे होता है, that thing we will see afterwards. Okay, that thing we will see afterwards. Any question so far? This was important, so that thing I have explained. Any question, please ask, otherwise we will proceed. I am waiting for your response. I am still waiting for your response. Louder. So we have talked about mod 1 also, we will proceed for mod 2. Now mod 2 is 9 bit. Remember, mod 2 is 9 bit. Mod 1, mod 0 both were 8 bit. Mod 0 was synchronous, mod 1 was asynchronous. Now we will talk about mod 2. So what is mod 2? See here. Please read this. Whatever I have explained you, everything is available here. Baud rate for mod 1, I have told you it is depends upon timer 1. तो टाइमर अब तक मैंने नहीं लिया है, so this thing I will explain you afterwards. Okay, so baud rate for mod 1 I will explain you afterwards. Yes, mod 2 now. You know the mod 2 is a multi-processor communication. Okay, that is a 9-bit UART. Your baud rate is 1 upon 32 of the crystal frequency, या फिर 1 upon 64 of the crystal frequency. Okay, now here important thing is that in your mod 2, actually this is similar to mod 1. Mod 2 is similar to mod 1 except that 11 bits are transmitted or received. Okay, again I'm repeating, your mod 2 is similar to mod 1 except that the 11 bits are transmitted or received. So which are the 11 bits? The 11 bits are one start bit, 8 data bits, one programmable ninth data bit. So programmable data bit. So that is one programmable data bit plus one stop bit. Okay. So 1 plus 8 plus 1 gives you 11. Gives you 11. Okay. Now here during the transmission, the ninth data bit, this programmable data bit, ninth. Okay, the ninth data bit is copied from bit TB8. TB8 is from SCON register. TB8 is from SCON register. Okay, TB8 is from SCON register. So what I have told you, that during the transmission, the ninth data bit is copied from bit TB8 of SCON. तो आपका जो नाइन्थ बिट है, सी आर नाउ, आप ट्रांसमिट कर रहे हो, सी द फिगर, राइट? एस बफ, दैट इज a 8-bit data is available here. Then this 8-bit is available here. See the other bits which are added: start bit which is always 0, stop bit which is always 1. But can you see there is a ninth bit? This programmable data bit can be your parity bit. Can be your parity bit. ओके, सो नाइन्थ बिट इज पैरिटी बिट. तो नाइन्थ बिट जो पैरिटी बिट है, हम वो कहाँ से लेंगे? वो हम लेंगे एस्कॉन रजिस्टर से. कौन से बिट से? TB8 से. कौन से बिट से? TB8 से. सो दिस नाइन्थ बिट while transmission, this ninth bit is copied from TB8 so that it becomes 11 bit. So that it becomes 11 bit. ओके, TI का फंक्शन वही है जो मॉड 1 में हमने देखा था. देन उसके बाद क्या होगा? देन यू हैव अ फ्रेम. कैन यू सी द फ्रेम? Can you see the frame which is of 11 bits? 1 plus 8 plus 1 plus 1. So 11. 11 bit ka frame. 11 bit frame. And you have a clock. Mod 2 mein it is either 1 upon 32 clock frequency, crystal frequency, या फिर 1 upon 64 crystal frequency. And then it is transmitted. सो 9-bit पैरेलल टू सीरियल कन्वर्जन. ये हमको जो डेटा मिल रहा था ये पैरेलली मिला है, लेकिन ट्रांसमिट जब हम करेंगे TXD से तो वो सीरियली ट्रांसमिट होगा. तो वो सीरियली ट्रांसमिट होगा. ओके, नाउ दिस वाज हैपनिंग फॉर द ट्रांसमीटर. रिसीवर में क्या है? रिसीवर में क्या है? ओके, तो रिसीवर में क्या है? वी विल सी नाउ. ये हो गया ट्रांसमीटर सेक्शन. वी विल सी व्हाट इज हैपनिंग इन द रिसीवर सेक्शन. वी विल सी इन द रिसीवर सेक्शन व्हाट इज हैपनिंग. Yes, see the receiver. You have received the data which is of 11 bit. Then comes serial to parallel. Then you have got this stop bit. See the TB8. Now this TB8 is copied in RB8. TB8 is copied in your RB8 while receiving the data. Then you have the data D0 to D7. And then you have a start bit. Okay, you have a start bit. So while receiving the ninth parity bit is copied in RB8. RB8 कहाँ पे है? RB8 है SCON register में. RB8 क्या है? RB8 is available in SCON register. So from this data frame, you are interested in the data. So you have extracted the data. It is available in SBUF. From this, I am reading the SBUF so that it is available in the accumulator. Any question, please ask. Any question, please ask. हाँ, कौन सा वाला? टीबी वाला? दिस वन? लाउडर, आपकी आवाज नहीं आ रही है. Programmable 9 bit. This RB8 you are talking about? या TB8? क्या क्या क्या? हाँ हाँ, यस, पैरिटी बिट ना, पैरिटी बिट. यस, हाँ. तो ये जो पैरिटी बिट है, तो हमारे डेटा के साथ हमेशा क्या जाता है? स्टार्ट बिट जाता है और स्टॉप बिट जाता है. लेकिन अगर मुझे डेटा चेक करना है, क्योंकि ड्यूरिंग द ट्रांसमिशन इट शुड नॉट हैपन कि मैं नंबर ऑफ वंस अगर 3 भेज रहा हूँ और रिसीवर को नंबर ऑफ वंस 4 मिल गए. आई एम टॉकिंग अबाउट द डेटा. So in that case, the checksum parity is checksum parity or checksum bit is sent. तो अगर even parity है तो parity bit will be sent as 0. So 0 is sent for even parity and 1 will be sent for the odd parity. तो ये 0 और ये जो 1 है, this is your ninth bit. This is your ninth bit. So if your number of ones are odd, then your parity bit will be 0. Sorry, if the number of ones are odd, then your parity bit will be 1, and if your number of ones are even, your parity bit will be 0. So this ninth bit will be taken during the transmission. It will be taken from TB8, and while reception, that TB8 bit will be copied in RB8 of SCON register. अभी समझा? अभी समझा आपको? हाँ. So that is what is happening in mod 2. That is what is happening in mod 2. Okay. So baud rate के बारे में मैंने आपको बताया. But this baud rate detail baud rate explanation will happen afterwards. Okay. तो हम अभी फिलहाल उसमें नहीं देख रहे, वो हम देखेंगे बाद में. So we have done with mod 0, mod 1, mod 2. Now the last mod, that is mod 3. Last mod is mod 3. So pay attention for mod 3. Please go through this transmission reception. Yes, you can also see what do you mean by multiprocessor communication. Okay. Yes, see at the mod 3 now. अभी mod 3 के बारे में क्या है? This is a very easy. Mod 3 is same as mod 2. Mod 3 is same as mod 2, except that the baud rate is determined as in mod 1. Okay, so mod 3 is the same as mod 2 in all respects except the baud rate. क्योंकि mod 2 में baud rate था 1/32 या फिर 1/64, लेकिन mod 3 में it is variable. That means it depends upon timer 1. That means it depends upon timer 1. खत्म. So baud rate in mod 3 is variable and generated using timer 1, similar to mod 1. Any question in mod 3? Any question in mod 3? Any question? Okay. So we have done with the mod 0, mod 1, mod 2 and mod 3. And here we have done with the special function register, that is your sbuff. We have done with the scon. Okay. Then pcon register is left. Okay. Pcon register is left. So regarding the pcon register, okay, regarding the pcon register we will see afterwards. Okay. तो pcon register के बारे में okay, that thing I will explain you afterwards. Okay, so what I have to say that we have studied about sbuff, scon register in detail. Pcon register is left, so this thing we will see afterwards. In the scon register, We have seen different four modes: mode 0, mode 1, mode 2, and mode 3. And we have to see the baud rates associated with mod 1 and mod 3, because they are set by the timer 1, okay. So this thing I will take afterwards. Is it clear to everyone now? Is it clear to everyone? Okay. Now write down the fresh heading. We have done with the we have done with the serial communication. याद में रखना सीक्वेंस. हमने पहले इंटरप्ट्स देखे, इंटरप्ट्स के रिलेटेड स्पेशल फंक्शन रजिस्टर्स देखे, बाद में हमने सीरियल कम्युनिकेशन देखा, उसके रिलेटेड हमने स्पेशल फंक्शन रजिस्टर्स देखे. अभी हम आगे बढ़ रहे हैं, अभी हम टाइमर्स और काउंटर्स देखेंगे. Now we will see timers and counters. Okay, so you can write down the heading as timers and counters. Write down the heading as timers and counters. Write down the heading as timers and counters. Okay. Now regarding the timer and counter, okay, before I proceed further, एक बात let me tell you, I have forgotten to explain you that thing also. We have studied in the pin configuration. We have studied in the pin configuration that, just a minute. Yes. When we were talking about 8051, when we were talking about the 8051, I have talked about different ports. Port 0, port 1, port 2, and port 3. Okay? So we have talked about these ports. Now regarding the port 0, I forgot to tell you one thing, that these port 0. Can anyone of you tell me where is your port 0? At which side? Top left, top right, bottom left, bottom right. Where is your port 0? Port 0 pins. Top, top right. Here, this side. Am I right? So, in this section, you have the port that is P0.0 to port P0.7. Now, these are the ports, port 0.1, port 0.2. Now these ports, whenever you are using for the data transfer, पोर्ट से हम अगर अगर कुछ डेटा ट्रांसफर कर रहे हैं, here we require a pull up registers when used as an IO port, when we are using as an IO port. Now when you are using this port as an IO port, what we have to do, we have to connect, see the section P0.0, P0.1, P0.2, P0.3. So these are the ports. So we have to connect external registers. We have to connect, these are called as pull up registers. Whenever you are using this port as an IO port, इनपुट आउटपुट, पैरेलल कम्युनिकेशन में अगर मुझे पोर्ट जीरो को यूज करना है, आयो कम्युनिकेशन के लिए यूज करना है, तो इन दैट केस आई हैव टू यूज द पुल अप रजिस्टर्स. दिस इज ओनली एप्लीकेबल फॉर पोर्ट जीरो. पोर्ट वन हमको पुल अप रजिस्टर्स लगाने की जरूरत नहीं है. पोर्ट टू पुल अप रजिस्टर्स लगाने की जरूरत नहीं है. पोर्ट थ्री ऑल्सो पुल अप रजिस्टर्स लगाने की जरूरत नहीं है. बट हमको अगर पोर्ट जीरो हमको यूज करना है आयो पोर्ट, देन एक्सटर्नली वी हैव टू कनेक्ट द रजिस्टर्स. सो देर आर टोटल 8 ports associated with port 0, so we have to connect 8 pull up registers. Okay, so I can show you the figure for that. I can show you the figure for that. See here, सबको स्क्रीन दिख रही है सबको? हाँ. So this thing I have left to explain you, that can you see here port 0 to port 7? These are the port 0. If I am using as an in IO port, in that case this is how the connection has to be done. हमको 10K का रजिस्टर लगाना पड़ता है. 1 2 3 4 5 6 7 8 8 रजिस्टर्स लगाने पड़ते हैं हमको, so that it should work as an IO port. This is only applicable for port 0, which is हमको ये सब प्रोविजन पोर्ट 0 के लिए ही करने पड़ता है. That is not done for port 1, port 2 and port 3. Okay, so if you read here, is an 8-bit open train bidirectional IO port. It occupies 8 pins, pin 32 to 39. Since all the pins are open drain, to use P0 as an input or output, the external pull-up registers of 10 kilo ohms, value should be greater than 1.42 kilo ohms, must be connected with each pin as shown in figure. As shown in figure. Okay, so when I will be explaining when I will be explaining you about this port 0, I'll be explaining you this in detail. So that time also I'll be able to explain you how do we have, just a second. Yes. So the main reason behind applying the pull-up registers is that your, your pins are open drain. Can anyone of you tell me why, what do you mean by open drain? EDC में क्या होगा? What do you mean by open drain? Yes, anyone? What do you mean by open drain? No one? Yes? ड्रेन टर्मिनल खुला रहेगा. और उसका क्या, और क्या मतलब है? ओके, यू जस्ट सी व्हाट डू यू मीन बाय ओपन ड्रेन. ओके, ये जो पिन्स है दीज आर ऑल ओपन ड्रेन्स. इसलिए to use them as an input and output, we have to connect the external pull-up register of 10K. Okay, so please see what do you mean by open drain, and I will ask you afterwards. Okay, what do you mean by open drain? So come to our explanation about this the previous one, timers and counters. So when you talk about the timers and counters, this is important. I have told you that when you are using the 8051 to count the external event, so ये आपका 8051 है और एक कुछ तो भी एक्सटर्नल इवेंट है, उसको मुझे काउंट करना है. सो देन यू आर यूजिंग द सेम टाइमर एज अ काउंटर. सो हाउ मेनी timers you have timer 0 and you have timer 1. So this timer 0 can be used as a counter also. This timer 1 can be used as a counter also. If I am using to count the external events, then this timer 0 is called as a counter. Same thing applies for timer 1 also. But if I'm using this timer 0 to give the clock pulses to the external device, if I'm using this timer 0 to give the clock pulses to the external device, then this work as a timer. Okay, so you can work as a timer also, as well as you can use as a counter also. So that difference you should know. Okay, now in this case, when you talk about timer 0, this timer 0 and timer 1 both are off. Tell me the size of timer 0 and timer 1. Tell me the size of timer 0 and timer 1. We have done this while going through the special function registers. When we were talking about the memory, can anyone of you tell me the size of timer 0 and timer 1? Yes, it is 16 bit. It is 16 bit. So your timer 0 and your timer 1 are 16 bits. Your timer 0 consists of, timer 0 consists of TL0 and TH0. तो आपको आपके जो मेमोरी है उसमें आपको ये देखने को मिलेगा TL0 and TH0. So TL0 is of 8 bit and your TH0 is of 8 bit. दोनों को मिला के बनता है 16 bit of timer 0. The same thing applies here. Here you will have TL1 and here you will have TH1. दोनों को मिलके बनता है 16 bit. So this is 16 bit as well as this is 8 bit and this is 8 bit. दोनों को मिला के बनता है timer 1 of 16 bit. So this is also 16 bit. This is also 16 bit. Is it clear to everyone? Is it clear to everyone? तो हाँ, तो आपकी मेमोरी में आपको ये TL0, TH0, TL1, TH1 ये देखने को मिलेगा. कोई मुझे बता सकता है TL0 का बाइट एड्रेस क्या है? अगर आपने ड्रॉ किया होगा, आपके पास अवेलेबल होगा, तो यू कैन जस्ट टेल मी व्हाट इज द बाइट एड्रेस ऑफ TL0. ओके, व्हाट अबाउट द TH0 बाइट एड्रेस? TL1 8. ओके, एंड TH1? ओके, एक बार मुझे फिर से बताओ, TL0 का बताओ. 8AH. TH0 का बताओ. TL1 का बताओ. और TH1 का बताओ. 8A, 8B, 8C, 8D. Okay, so you will be able to remember this in a proper way. Now, what are the special function registers which are associated with the timer and the counter? Which are the special function registers which are associated with the timer and the counter? They are TCON register and TMOD register. TCON register and TMOD register. TCON register and TMOD register. So these are the two registers which are special function registers which are associated with the timer 0 as well as timer 1. Can anyone of you tell me what is the size of TMOD and what is the size of TCON? Yes, both are of 8 bits. आपको मेमोरी में दिखाई देगा. वो 8 बिट का है. ओके, सो बोथ दिस टिक ऑन रजिस्टर एंड टी मॉड रजिस्टर आर ऑफ 8 बिट. ओके, something more on this we will see in the slide, sorry, in this ebook. Let me find out. Yes, can you see here TL0 TH0? 16-bit timer 0 register is TL0 and TH0. Okay, so D0 to D7, D0 to D7. ओके, सो पूरा सब मिलके बनता है D0 से लेके D15. Similarly for timer one also the same thing. Okay, so already I've explained you, nothing new in this. We will be talking about the timer and counter. So to explain you, this is the, yes, I want everyone to pay attention here now. नाउ आपका, आप 8051 को काउंटर बोल के यूज कर रहे हो या फिर आप 8051 को टाइमर बोल के यूज कर रहे हो, फॉर दैट दिस इज द फिगर, फॉर दैट दिस इज अ फिगर. ओके, सी ऑन ऑल ऑफ यू, I want everyone to have a keen observation. Okay, see properly. This section is used when you are using as a timer, and this section is used when you are using as a counter, when you are using as a counter. Okay, so this section is used when you are using as a timer, and this section is used when you are using as a counter. So when you are using as a timer, see here, you are giving the clock to the outside. Okay, see here, you know you have a oscillator frequency. If the oscillator frequency is of x megahertz, for example, that oscillator frequency of x megahertz is always divided by 12, is always divided by 12. If you remember, while explaining you the pin configuration of 8051, I have explained you xtal 1, xtal 2, xtal 1 that is crystal 1, xtal 2 that is crystal 2. These are the two pins. At these two pins you are connecting the oscillator frequency. So this oscillator frequency is divided by 12, and whatever you get the output of that, that is utilized as a clock pulse to carry out the operations of 8051. Again I am repeating, listen properly. When you are connecting your xtel 1 and xtel 2, these two pins with the crystal frequency, whatever the crystal frequency you have, that will be always divided by 12. After dividing by 12, whatever the output you get, that is actually, that is a frequency what जो आपको मिलेगा, that is the frequency, or that is the clock pulses which will be utilized to carry out the internal operations of 8051. Because whatever the operations you do, that will be always related or associated with your clock frequency. Okay, clock frequency. तो यहाँ पे देखो, you have an oscillator, you have divided by 12. So when you have, suppose oscillator frequency is x megahertz, so x megahertz divided by 12, you have got this clock. Can you see the clock? Can you see the clock? So this clock will be used for carrying out the internal operations of 8051. या फिर this clock can be given as an output. तो can you see here, यहाँ पे एक स्विच है, ये कभी ऊपर जाता है ए के पास, ये कभी जाता है नीचे बी के पास. अगर मैं टाइमर बोल के यूज करूंगा तो ये स्विच जाएगा ए के पास, और अगर मैं काउंटर जैसे यूज करूंगा तो ये स्विच जाएगा बी के पास. तो जब अगर मैं ये टाइमर बोल के यूज करूंगा तो ये ऊपर जाएगा. सो दिस क्लॉक विल बी अवेलेबल एंड दैट इज गिवन एज द आउटपुट. सी हियर, टू टाइमर क्लॉक सोर्स, ये आपका क्लॉक सोर्स बन गया ना अभी बाहर के लिए. या फिर इंटरनल ऑपरेशन के लिए. So to carry out this, you have this C slash T bar. Remember this, what does it mean? It means C counter, T timer, but T timer is active low. It is active low. When your C slash T bar is equals to 0, that means you are using as a timer because timer is active low. But when this C slash T bar is equals to 1, देन यू आर यूजिंग एज अ काउंटर. तो यहाँ पे देखो क्या है, कैन यू सी यर सी स्लैश टी बार इज इक्वल टू 0 है, और यहाँ पे देखा सी स्लैश टी बार इज इक्वल टू 1 है. सी स्लैश टी बार इज इक्वल टू 1 है, इसका मतलब यू आर यूजिंग एज अ काउंटर. इन दैट केस दिस स्विच विल बी मूव टुवर्ड्स द बी, दैट विल मूव टुवर्ड्स द बी. बट व्हेन यूर सी स्लैश टी बार इज इक्वल टू 0 है, देन इट विल बी मूव टुवर्ड्स अपवर्ड. अब ये सी स्लैश टी बार कहाँ पे, दिस थिंग इज अवेलेबल इन टी मॉड रजिस्टर. तो जब हम टी मॉड रजिस्टर पढ़ेंगे उसमें ये सी स्लैश टी बार है, उसमें ये सी स्लैश टी बार है. तो वो बिट अगर 0 है आपको पता है आई एम यूजिंग एज अ टाइमर, वो बिट अगर 1 है तो आपको पता है आई एम यूजिंग एज ए काउंटर. ओके, तो ऊपर का सेक्शन मैंने ले लिया, नीचे का सेक्शन में क्या है देखो, नीचे का सेक्शन में क्या है देखो. तो काउंटर बोल के दैट मीन्स यू आर काउंटिंग द एक्सटर्नल पल्सेस. ओके, तो ये स्विच सी स्लैश टी पर वन हो जाएगा, ये नीचे आ जाएगा. नीचे आने के बाद देखो क्या है, काउंटर क्लॉक, आप काउंट कर रहे हो. ओके, या फिर एक काम कर सकते हैं, इंस्टेड ऑफ शोइंग इन दिस वे यू कैन डू वन थिंग. हाँ यस, यू हैव एन एक्सटर्नल सिग्नल, यू हैव एन एक्सटर्नल सिग्नल. अभी आपका एक्सटर्नल सिग्नल आप कहाँ पे कर रहे हो, that external signal is available at T0 or T1. Can any one of you, those who have pin diagram with them, can any one of you tell me T0 or T1 इनका पिन बताओ. T0 आपका पिन है का, कौन सा पिन है, पिन नंबर 14. वेरी गुड, पिन नंबर 14, पिन नंबर 14. क्योंकि आपको मैंने बताया था पोर्ट 3 आर हैविंग अल्टरनेट फंक्शंस, port 3 are dual functions. So in that pin number 14 is T0. Okay, pin number 14 is T0. And what about T1? Pin number 15. Yes, pin number 15 is T1. तो आप जब पिन नंबर 14 को जब आप फ्रॉम आउटसाइड वर्ल्ड इफ यू आर कनेक्टिंग, जो आपको काउंट करना है, देन इट विल बी गिवन एट T0. अगर आपको पिन नंबर 15 पे अगर कनेक्ट करना है तो यू आर कनेक्टिंग विद T1. इसलिए यहाँ पे क्या लिखा है, एक्सटर्नल सिग्नल ऑन T0 या फिर T1. ये देखो ये क्लॉक आ गया, एक्सटर्नल से आ गया. सो फ्रॉम एक्सटर्नल सिग्नल यू आर गेटिंग दिस क्लॉक पल्सेस एंड देन यू कैन काउंट देम, देन यू कैन काउंट देम, देन इट यू कैन काउंट. ओके, तो अगर मुझे टाइमर बोल के यूज करना है तो यहाँ से ले लो, ये ऊपर जाएगा, यू आर हैविंग द क्लॉक. अगर हम काउंटर बोल के यूज कर रहे हैं तो T0 या फिर T1 यूज करो, काउंटर क्लॉक आ गया और दैट कैन बी रेड. आई होप यू हैव अंडरस्टूड द कंसेप्ट ऑफ क्लॉक सोर्स फॉर टाइमर स्टेजेस. एनी क्वेश्चन यू हैव, प्लीज आस्क. एनी क्वेश्चन, प्लीज आस्क. Okay, so I think we can stop for today. Manpreet, tomorrow I do not have lecture, na? हाँ हाँ, tomorrow you have test. Yes, tomorrow you have test. Okay, so all the best for your test. And related with my microcontroller subject. Okay, whatever I have done till today, you please do it properly. And if some portions are left, I will do one thing, I will be giving you some questions. Okay, so those questions also you study for your test. Okay, so that will be like a question bank. Okay, so I will be giving you that question today itself, till evening, to the Manpreet, and she will be sharing with you all. So you please go through that question bank also and try to understand by yourself. Meanwhile, if you have any questions or any doubt, you can call me at any time. Okay. So once again, all the best, and we can stop for today. Okay. मनप्रीत अटेंडेंस हो गया क्या? एक बार ओके, अटेंडेंस नहीं हुआ, सो प्लीज टेक ओरली.